Okay, so displacement is end minus beginning. So if you look at the module, the first link in the module is not an assignment. It is the like schedule of what we're doing. That schedule is where I put the class notes for each day and where I put the answer keys. So if we do notes in class like this, like if I record like this, that's where I put those notes. And then, so that's what, yeah, these. So the homework notes are actual assignments, so they go within the module, but any class notes are not required to be watched. They're just extra resources. Those go under the first link. Yeah, I'll show you guys after this. I'll show you where I put them all. Okay. Part B, find the average velocity. So what should the word velocity make you think of? Derivative or slope, right? But when it says average, what should it make you think of? Yeah, regular slope, right? Old school slope is what it should make you think of. So we're going to say s of 6 minus s of 0 divided by 6 minus 0. Does that make sense? So old school slope. Average velocity is old school slope. Now, what type of units do we have for our outputs, for our y coordinates? Yeah, so it's units. And then our x coordinates is time, that's seconds. I can tell my x coordinate is time because it says s of t, t for time, which they said is seconds. And then the output is how far the particle is moving. They didn't tell me feet, whatever, so I'm just using UN for units, or like it's talking about a coordinate axis, so it would be like boxes, like 1 box, 2 box, 3 box, whatever. Okay, so we have 8 minus -4 divided by 6, so that's 12 over 6, which is 2 units per second. How do your brains feel? Brains are good? All right, C. Find the value for t for which the particle is moving downwards. So when we talk about the particle moving, are we still talking about the position, or should we talk about something else? So these were both using the position. Are we still talking about the position function, or should we talk about something else now that we're talking about the particle moving? Velocity. So now that the particle is moving, now we're talking about the velocity. So we need to get the velocity function. So if I take the derivative of this, what is the derivative? Minus 6t plus 8. And to figure out where it's moving downwards, we have to do a sign chart. Okay, so left is negative, right is positive. Downwards is negative, upwards is positive. Does that make sense? How do we find the numbers on our sign chart? We need to figure out where it equals 0. Okay, how do we take a quadratic and figure out where it equals 0? Yeah, set it equal to 0 and factor it. Okay, so what are two numbers that multiply to 8 but add to -6? -4, -2. So we got t minus 4, t minus 2. Okay? Yeah.
What would you do for like bigger number if you don't have an interval? So like you find where it equals 0, but when it gives you an interval, you do like 1 to 9. But what would you do if you don't have an n number?
Well, that's kind of happening here because it just says t is greater than 0.
Yeah, that's what I mean.
Yeah, you'll see in a second because we're going to do it. All right. So our two answers for t are what? 4 and 2. Okay, so we're going to make a number line. What is the very smallest end of our number line? 0. And then we got 2, and then we got 4, and I'm putting a right arrow for infinity. It's going to go forever. Okay. What's a number between 0 and 2 that I can test? 1. What's a number between 2 and 4 that I can test? What's a number bigger than 4 that I can test? 5. Okay. So I want to know where the derivative is positive, where the derivative is negative, and so I'm going to plug the numbers in here because it's a little bit easier to evaluate without a calculator than it is to evaluate it right here. Okay? So I have 1 minus 4. Is 1 minus 4 positive or negative? Okay, I've got 1 minus 2. Is 1 minus 2 positive or negative? Okay, so I've got a negative times a negative. What is that answer? Okay, so positive. Okay. Then I've got 3 minus 4. Is that positive or negative? Then I've got 3 minus 2. Okay, so overall, is that positive or negative? Okay. Then I've got 5 minus 4. Then I've got 5 minus 2. And overall, that is... Okay. So they want to know where the particle is moving downward. Where is the particle moving downward? Between 2 and 4. Okay, so we're going to say it's moving downward where t is between 2 and 4. I'm not including 2 and 4 because at 2 and 4 exactly, the particle is not moving at all. Okay. Now, if we were talking about moving upward, we would say for upward, it is between 0 and 2, and for any value greater than 4, any time greater than 4. So it starts moving upward at 4, and then it moves upward forever. Never switches directions again after that. So that kind of answers your questions about what if we don't have an upper bound for our time interval, and that's how you would answer that question. Does that make sense? All right, find the values for t for which the particle is not moving at all. What are those values? 2 and 4. That's where your velocity is 0. All right. Accelerating, decelerating, what do we need to do before we can answer those questions? Yeah, we need the derivative of velocity, and then we're going to need that number line. So what's the derivative of velocity? Okay, 2t minus 6. Now, I know it's silly to factor this, but I still do because I kind of like plugging stuff into the factors. So I'm going to do that anyway. So 2 times t minus 3 equals 0. Are you guys comfortable with that? Okay. So t equals what? 3. Okay, so on my number line, I'm going to put 0, and I'm going to put 3. And what number can I plug in between 0 and 3? And what number can I plug in bigger than 3? 5, okay. So 2 is always positive, so I'm going to put positive first. And then 1 minus 3 is negative, so that first one is a negative. 2 is always positive, and then 5 minus 3, and so I get positive times positive is positive, okay? Find the value of t for which the particle is accelerating. So where on the sign chart is t accelerating? 3 infinity. So we're going to say t is greater than 3, or if you wanted to say 3 infinity, you could say it like that. That would be fine as well. So either notation is fine. Mm-hmm. 2, 4 is fine. Yep. Both notations are totally acceptable. Find the values of t for which the particle is decelerating. So 0. And include 0, because if we plug 0 in, we're going to get -6. We took the velocity and we took the derivative. So 2t minus 6. Mm-hmm. Mm-hmm. Now, the reason that we knew that when we answered F, we should think about including 0 is because 0 was not one of the values where A of t equals 0. Does that make sense? 0 was not one of the values where A of t equals 0. Okay? So it wasn't like we got 2t times t minus 3. Then 0 would have been one of the values where the acceleration was 0. It was 2 times t minus 3, which means that 0 is part of the interval. Okay? The other way you could figure that out is by taking 0 and plugging it in. You can see that 0 is one of the values when you plug it in. 0 is one of the values that makes it negative. Okay? That can kind of help you know that you should include it as well. Yeah. Okay. All right. How are your brains feeling about that? Brains are good? Okay. What else did we want to go over? 7? 7 or 9? 9, would we rather do 9 or would we rather do 7? 9? We prefer 9? Yeah? Okay. So part A says the particle's velocity at t equals 4. So what do we need to do to figure out the velocity at t equals 4? Yeah, we need the equation for velocity for sure. So we have the equation for the position, which is x of t. So they kind of go back and forth between using x of t, which tells you, when they do that, when they say x of t, they're telling you that it's moving left and right along the axis. Does that make sense? Sometimes they'll give you y of t and they're telling you it's moving up and down along the y-axis. So they gave you x of t instead of s of t. They're just giving you some information about how it's moving. And so now we're going to go ahead and find our velocity equation, which means we need to find the derivative. So our first term is going to be t squared, and then we do have a minus, so it's kind of hanging out there. Minus, what's our next term? 8t, okay, and then plus 15, okay. Now, we don't even have to do anything like set it equal to 0 or whatever. I mean, we might have to later, but we don't have to for this problem. This problem says find the particle's velocity at t equals 4. So what should we do? Set it equal to 4 or plug in 4? Plug in 4. How do you know to plug in 4 and not set it equal to 4? They're telling you t is 4. Does that make sense? So they're not saying what is the velocity, or they're not saying the velocity is 4, when is the velocity 4? They're saying the particle's velocity, find that. That time is 4. Okay, so plug in 4. So we got 16 plus 15 minus 32 equals -1. How can a velocity be negative? It's going to the left. The particle's moving to the left. Okay. What are the units on this? Think about your slope, right? Slope, we have our y-coordinate divided by our x-coordinate. What are the units for our y-coordinate? Units. What are the units for our x-coordinate? It doesn't really tell you, does it? Probably seconds. So we'll just say units per second. Okay. All right, B. Acceleration. All right, so now we need our formula or our equation for acceleration. So what do we do next? Derivative, right? Our velocity derivative is 2t minus 8. And now what are we doing here? Plugging in for, what do we get? 0. What are the units for this? Yeah, so take the output from velocity, that's your y-coordinate, divided by your x-coordinate, which is still seconds. So output from velocity was units per second. Your x-coordinate is still seconds. And you get units per second, which is units per second squared. Which is weird, but that's how it works. So 0 units per second squared. Okay, the times when the particle is at rest, what do they want us to do? Say it again. Find the zeros of which one? The velocity. So we're going to take the velocity, set it equal to 0. Now, when you guys are doing FRQs, the sign chart is typical. They're going to be expecting to see it, but the sign chart is not justification. You cannot say, I saw a plus on my sign chart and that's how I knew. Does that make sense? You cannot say that. You can say V of t greater than 0. That's a plus on the sign chart. Does that make sense? V of t greater than 0, that's a plus on the sign chart. That is justification. My sign chart said plus is not justification. Does that make sense? Okay. So we can say things like V of t equals 0, V of t less than 0, V of t greater than 0. We can say things like A of t equals 0, A of t greater than 0, A of t less than 0. We cannot say my sign chart said this. They're expecting to see the sign chart. You don't have to scribble it out, but you cannot reference it as justification. Does that make sense? Okay. Because again, mathematicians grading our papers, they don't like us to use gimmicky things. A sign chart is a little bit gimmicky. Okay. All right, V of t equals 0, so we're going to say t squared minus 8t plus 15 equals 0. So we're looking for what multiplies to 15 but adds to negative 8. Okay. So what does t equal? T equals 5 and 3. Those are the two times when the particle is at rest. What about when the particle is not accelerating? Is that 4? How do you know? Because the acceleration at 4 is 0. So that's when we would take A of t, set it equal to 0, which is at t equals 4. All right, how do you find the particle's initial velocity? V of 0. So the starting time, just verify the starting time is 0. So the starting time, it could be 5 if they wanted to be weird. Typically it's 0, but they could have said in a problem for t is greater than or equal to 1, for t is greater than or equal to something. So the initial value would always be wherever they told you to start. So they told you to start at 0. So when you start at 0, what do you get? 15 units per second. Cool. Yeah. All right. Feel a little bit better about that assignment? Sorry I left you guys high and dry yesterday. Not my intention.